Today we're going to be talking about polynomial long division. And we actually mostly care about this chapter because it links into the next two sections. We actually don't test polynomial long division as a skill in silo very often because that's actually technically an intermediate algebra skill. But it is used in the next section in order to find the zeros of polynomials that cannot be factored, and in the section after that in order to find all the asymptotes of a rational function. So you can't do the next two sections if you don't understand this section. So even though this was technically an intermediate algebra section, it is worth pausing, practicing, having its own homework on, and making sure that we really have this skill down, because the rest of the class will be a really bad time if we don't have this skill down. So let's get into this polynomial long division. So before we start dividing with polynomials, let's remind ourselves on how literal long division works. So I've got an example here, but let's just do it with a different example. So let's say I had, 645 divided by 5. First thing you would ask yourself is, how many times does 5 go into 6 without going over, which is saying I want to multiply 5 into 6. Well, it goes in once. Then you would do 1 times 5 is 5. And then that would tell you to subtract 5. 6 minus 5 gave you 1. Drop down the 4. Drop down the 5. Great, I dealt with that first place value. Then you would say 5 goes into 14 how many times? It goes in twice. So then you do 2 times 5 is 10. You would subtract 10. 1 minus 1 is 0, that's good. 4 minus 0 is 4. Minus 5, actually I technically should have moved the other way around. We do the 4 minus 0 first, but that's fine. We know the 14 minus 10 is 4. Drop down the 5. 5 goes into 4. Ooh, it doesn't go into 4, so I gotta say 5 goes into 45 how many times? 9. So then you do 5 times 9 gives us 45. So then we subtract 45, and then I get a remainder of 0. And the fact that we got a remainder of 0 means 5 is a factor of 645. To this other example that we have here, since we got a remainder of 1, that meant that 3 was not a factor of 178. We even then could take this one step further and say, for example with 645, that I know 645 is going to be equal to 129 times 5 plus my remainder, which is 0, which is true. 129 times 5 gives me 645. Same thing even with the one that had a remainder. I know that in this case 178 is equal to 3 times 59 plus my remainder of 1. So there's multiple different ways I could kind of rearrange these to talk about it. I could also say that 178 divided by 3 is equal to 59 plus 1/3, or in this case I could say that 645 divided by 5 is equal to exactly 129. There's more than one way I can rearrange this relationship between my dividend, my divisor, and my quotient. My dividend being the thing I'm dividing, my divisor being the thing I'm dividing by, the quotient being the answer, and the remainder being whatever is still left over. And you might be like, why are you telling me this? This is not the focus of this class. And it's not, but it's because the way that long division works with numbers like this is the same as how it works with polynomials, actually. So if you want to do 2 times x cubed minus 3x squared plus 4x plus 5 divided by x plus 2, you end up doing a similar process. So you're like, oh, how many times does x go into 2x cubed without going over? You do x times 2x squared. Then you do 2x squared times x plus 2. Subtract the result. Keep going. I'm going to go over a separate example here in a moment, so I'm not going to go through this per se step by step, although I encourage you after this video to kind of go through this step by step as well. This is from your textbook. But the actual process is really, really, really similar. And that's what we're going to be emphasizing today. And the reason why we care about that process is if I do that division, if this is my result and this is my remainder, this guy is equal to the thing I divided by times the result plus the remainder, which is actually a really, really cool idea. And if that remainder is 0, I've actually just factored this polynomial. And that's why we care about that. And so when they're talking about the division algorithm, they're telling us to do this process, where your original polynomial is going to be equal to the thing you divided by times your answer plus your remainder. That's kind of the colloquial way of saying that. The more formal way of saying that would be divisor times the quotient plus the remainder, and that the dividend is equal to that. And this is written out, but I think it actually makes the most sense if we just like really carefully step by step go through it without the answer already being written out per se. So if we want to divide this, this means we're doing 5x squared plus 3x minus 2 divided by x plus 1. And for our first step, we want to ask ourselves, x goes into 5x squared how many times, which is equivalent to saying x times what will give me 5x squared. So a lot of times if people can't visualize that, the way they actually think about that is you do 5x squared divided by x. Well, 5x squared divided by x leaves me with 5x, and x times 5x is indeed 5x squared. So that's actually my first result here. So just to emphasize, if you don't like thinking just kind of like to yourself like that, the way that you can always very systematically do this is you literally do this leading term, 5x squared, divided by this leading term, x, and that will give you that first result. You might be asking yourself, what about the plus 1? What about the 3x minus 2? We're going to care about that for the next step, but for the first step of figuring out what you write up here, you actually always just pay attention to those leading terms. Now for the next step, I'm actually going to use that because off to the side, I want to do 5x times x plus 1. 5x times x gets me 5x squared. 5x times 1 gets me 5x. And then I need to subtract that result, which means I need to distribute the subtraction to both terms. And I'm actually going to write it underneath here with that subtraction being distributed, because we're going to be subtracting 5x squared, and you have to subtract the 5x. You have to subtract the entire term, which means you have to subtract both. You have to distribute the subtraction to both. 5x squared minus 5x should give me 0 if I did it right. 3x minus 5x gets me negative 2x, and then you drop down the minus 2. Now I repeat the process. So I in particular want to say negative 2x divided by x, this leading term divided by this leading term, leaves me with negative 2. Another way of framing that is x times what gives me negative 2x, that's negative 2. Or if you want to use the language of regular long division, x goes into negative 2x how many times? Negative 2. Then off to the side, you want to multiply negative 2 times x plus 1. Negative 2 times x is negative 2x. Negative 2 times 1 is minus 2. And then you need to subtract the entire result. So I need to distribute minus a negative becomes adding 2x. Minus a negative becomes adding 2. So I do plus 2x plus 2 to subtract negative 2x minus 2. Negative 2x plus 2 makes 0. Negative 2 plus 2 also makes 0. So our remainder is 0, which is super nice, because what I just figured out was that 5x squared plus 3x minus 2 is equal to x plus 1 times 5x minus 2. And this also happened to be factorable, and you could confirm that as well. But sometimes it's not factorable, and you were able to still figure out these cool relationships, which is nice. Or not factorable by methods that we know. If it ends up this way, that means it's factorable in the grand scheme of things. But let's keep going. So let's say you had something like this. Well, first of all, pause the video and just set up the problem and make sure you've got that straight. And then restart it so that we can solve it together. So to set up the problem, you put this dividend here. So 6x cubed plus 11x squared minus 31x plus 15 divided by, and let me actually give myself some room to write things when we get results, 3x minus 2. That is your first step. You want to figure out 3x plus what gives me 6x cubed. So in particular, you can do 6x cubed divided by 3x. 6 divided by 3 gives us 2. X cubed divided by x gets us x squared. So that is 2x squared. And notice how I line up my place values to keep myself straight here. Then to the side, I want to do 2x squared times 3x minus 2. 2x squared times 3x gets us negative 6x cubed. 2x squared times negative 2 gets us minus 2x squared. And then I need to subtract the entire result. So that gets us negative 6x cubed plus 4x squared. And distributing that subtraction is where most people mess up if they do mess up in this process. So always as a sanity check, double check. If there's opposite signs here, there should stay opposite signs there. If they're not opposite signs there, and there were opposite signs here, you did something wrong, and double check your distribution. 6x cubed minus 6x cubed is going to leave us with 0x cubed, which is what I want. I'm not necessarily going to explicitly write that, but that's really what I've made when I've canceled that out. 11x squared plus 4x squared gives us 15x squared, and then I just drop down my other terms. I'm going to encourage you to pause this video and try to do the rest of the long division yourself, and then compare with what I get. Now I want to ask myself, 3x goes into 15x squared how many times? So I can explicitly do 15x squared divided by 3x. That leaves me with 5x, and 5x times 3x does indeed give me 15x squared. So I want to add 5x. Then I want to do 5x times 3x minus 2. 5x times 3x gets me 15x squared, just like I predicted. 5x times negative 2 gets me negative 10x. Then I have to distribute that subtraction, so that becomes minus 15x squared plus 10x. So minus 15x squared plus 10x. 15x squared minus 15x squared, that makes 0. Negative 31x plus 10x is 21x. Drop down the plus 15. As a final step, we want to ask ourselves, 3x times what gives me 21x? I can even explicitly do 21x divided by 3x to the side. That would just be 7. And then I want to multiply out 7 times 3x minus 2. 7 times 3x gets us 21x. 7 times negative 2 gets us minus 14. And then I want to distribute my subtraction, so that's minus 21x plus 14. 21x minus 21x makes 0, and I have a remainder of 29 this time. So this time this is not a factor. So this is our result of the division. That also means that this is equal to 3x minus 2 times 2x squared plus 5x plus 7 plus 29. So now I have to add on that plus 29 because I had a remainder before. I was secretly adding on plus 0, but adding on plus 0 doesn't do anything. And what way they want you to write your result is just going to depend on the context of the problem. Because it's also possible that they would just want you to write the result as your answer, 2x squared plus 5x plus 7, plus, and then 29 divided by the thing that you were dividing by. That would be another equivalent way of writing this answer. So just pay attention to how they ask you to write the answer. Do they want you to ask what the polynomial is equal to? In which case it's this. Do they want you to just write the quotient and the remainder? In that case it's this. Or do they want you to write it as the quotient plus that remainder divided by the thing you were dividing by to get what it's precisely equal to? In that case it's that. So just pay attention to those directions. Go ahead and pause this video and try to do out this long division yourself and then compare with what we get. So we have 4x cubed plus 10x squared minus 6x minus 20 divided by x plus 2. First thing we want to ask ourselves is x times what will give us 4x cubed. So we can do that to the side. 4x cubed divided by x gives us 4x squared. Then we want to go ahead and multiply 4x squared times x plus 2. 4x squared times x gives us 4x to the third. 4x squared times 2 gives us plus 8x squared. And then we want to subtract the results. So that gives us minus 4x cubed minus 8x squared. So now since our signs match here, they should also match here when I'm doing my subtraction step. 4x cubed minus 4x cubed gives us 0 by design. 10x squared minus 8x squared gives us minus 2x squared. And then we drop down our other terms. Now we want to repeat the algorithm. So I ask myself, x times what gives us 2x squared? Well, off to the side it can do 2x squared divided by x. That gets us 2x. Then I want to multiply that result by what I'm dividing by. So 2x times x gets us 2x squared. 2x times 2 gets us plus 4x. And then I want to distribute subtracting that result. So minus 2x squared minus 4x. 2x squared minus 2x makes 0. Negative 6x minus 4x gives us negative 10x. Drop down the minus 20. And of course I forgot to actually write down. Our result was 2x. I should have written that up there first. Last step, I want to figure out x times what gives us negative 10x, which I can explicitly divide to the side. Negative 10x divided by x is negative 10. And then I want to distribute multiplying that by x plus 2. Negative 10 times x is negative 10x. Negative 10x times 2 is minus 20. And then I want to subtract the whole thing. So negative times negative 10x is positive 10x. Negative times negative 20 is positive 20. So I'm doing plus 10x plus 20. That makes 0 and that makes 0. So we have a remainder of 0. I just figured out that 4x cubed plus 10x squared minus 6x minus 20 is equal to 4x squared plus 2x minus 10 times x plus 2, because there is no remainder, it's kind of secretly plus 0, which that is super nice because I just figured out x plus 2 is indeed a factor of this, which is how we're really going to be using this in the next section. For this next one, I would recommend setting up place value holders in general if you find that some of these are missing place values. And what do I mean by that? I mean that you really have 5x to the fourth plus no x's cubed minus 3x squared plus no x's plus 10. And you're dividing that by x squared plus no x's plus 2. For this particular problem, you're probably not as apt to necessarily get messed up if you didn't put in those place value holders. But in particular, like let's say there was an x term in what I'm dividing by and there wasn't here. If I just started moving across, I might find myself going with the wrong place value and trying to mismatch what's being subtracted where. And don't be thrown off by the fact that we're now dividing by an x squared. The process still works the same. I still want to figure out x squared times what gives me 5x to the fourth. So to the side I can do 5x to the fourth divided by x squared. That gets me 5x squared. And that's exactly what I'm going to line up above the x squared term. Then I want to distribute 5x squared times x squared plus no x's plus 2. 5x squared times x squared gets me 5x cubed. Oh wait, 5x to the fourth. Ooh, that was bad. 5x to the fourth. X squared times x squared is x to the fourth. 5x plus no x's gets me no x cubes. I'm just leaving that as a place value holder. 5x times 2 gets me plus 10x squared. 5x squared times 2, I should say, gets us 10x squared. And then we distribute the subtraction. So negative times a positive gives us negative 4x cubed minus negative 4x to the fourth. Sorry, I am just misspeaking all over today. Negative 5x to the fourth. Negative times positive 0, although for 0 the sign doesn't matter. Negative x cubed. Negative times positive 10x squared. Negative 10x squared. So I'm going to minus 5x to the fourth minus no x cubes minus 10x squared. That cancels out. That cancels out and makes 0. And then we have negative 13x squared. Drop down plus no x's. Drop down plus 10. And then as my last step, I need to figure out x squared times what gives us negative 13x squared. So I can do negative 13x squared divided by x squared to the side. That just gives us negative 13. So I want to do negative 13 times this entire thing in parentheses. Negative 13 times x squared gives us negative 13x squared. Negative 13 times no x's gives us no x's. Negative 13 times 2 gets us minus 26. And then I want to distribute the subtractions. So we're doing negative times a negative is a positive 13x squared. Negative times positive is minus 0x. Negative times a negative is plus 26. So we end up with positive 13x squared minus no x's plus 26. Negative 13x squared plus 13x squared cancels out to make 0. 0x plus 0x cancels out to make 0, and I'm left with 36. Should have also written this negative 13 up here. So our result is 5x squared minus 13 with a remainder of 36. So this guy was not a factor. As always, please feel free to check out your textbook for even more examples, and please ask your professor if you want some further assistance as well.